Jai Hind, myself Neha Garg. I am assistant professor in Ajay Kumar Garg Engineering College, and today's topic is NAND and NOR realization of gates. This topic has been taken from the subject Fundamentals of Electronics Engineering. So basically NAND gate, basically the universal gate. So what are the universal gates? Like NAND and NOR, NAND gate and NOR gate. Both these gates are used as a universal gate, because other gates like AND, OR, NOT, EXOR, XNOR, all these gates can be designed with the help of NAND and NOR. That's why NAND and NOR are termed as a universal gate. So how we can realize another gates with the help of the NAND gate realization, NAND gate. So like if we have a NOT gate, we can use the bubble method also. So here we are using the bubble method. So if we want to design the NOT gate, so NOT gate is equal to y is equal to a bar, and our NAND gate is y is equal to ab bar. So we have to realize the NOT gate with the help of the NAND gate. So if we see, we can put, if this is the expression for the NAND gate. If we put a is equal to b, so it will be a into a, so it will be a bar. So we can make the NOT gate by using NAND gate by making the two inputs equal. Like this is the NAND gate and both a and b input are equal. So this is the NOT gate. This is the NOT gate. So how we can design this NAND gate? We can see, if we make the two input a and b both are equal, then this NAND gate will work as a NOT gate. So this is how we can design the NOT gate with the help of a NAND gate. So we have to design the EXOR gate with NAND gate and using bubble method. Using bubble method, like how we can use the bubble method? Like this is the expression for the NAND gate. Now we have to design this expression using only NAND gate using the bubble method. So first of all, we have to design all this expression with the basic gate. Like a bar will be when we will pass it through the NOT gate. Now this is b, so this is the a bar b. After that a b bar, so a b bar for a, and after that b, it will be passed through b. So this will be a b bar. So this is how we have designed this expression with the help of the basic gates. Basic gates means only using AND or NOT. Now we have to design it with the NAND gate. So for designing with the NAND gate, we have to use that how we have to convert all these gates into the NAND. So AND will be converted into NAND by putting a bubble at the output. So we have put the bubble at the output, and we also place a NOT gate. Because by putting bubble at the output, a complement will be there. So to neutralize this, a NOT gate will be there. And this is the AND gate. So output, there will be bubble at the output and NOT gate will be there. And at the input of the OR gate, bubbles will be there, because OR gate will be converted into NAND if we put a bubble at the input. How? Like this is our OR gate and we put bubble at this end. So this will be a bar and this will be b bar. So it will be a bar plus b bar. So it will be a, according to De Morgan's, it will be equal to a b bar. So this is how OR gate having bubble at the input, it will work as a NAND gate. So this is how it will be converted into NAND gate. Now we have put bubble here, so we will put NOT gate here also. The place where we will put a bubble, we also put a NOT gate also to neutralize the effect. Now same number of NOT gate will be cancelled out. Now these circuits will be converted into this form. So now redraw this circuit using only NAND gate now. So this is how the XOR gate can be designed by using the NAND gate only. So we have designed the output of this, like here it will be A bar, here it will be A bar into B, total bar. This is the B bar, and this will be A dot B bar, and this will be A bar dot B bar, A dot B bar, total, and this will be equal to A bar B plus AB bar. So this is how we have designed the XOR gate by using NAND gate only and with the help of bubble method. This is the bubble method. Now we have to design the XNOR gate with the NAND gate, XNOR gate with the NAND gate. So expression for the XNOR gate is A bar B bar plus AB. Now we will design with this expression with the help of basic gates. So this will be A bar, after that this is B, this is B bar. So this is the, and after that A, B, and this is OR gate. This is AB, this is A bar, B bar. Now we have to convert it with the NAND gate. So for NAND gate, we will put bubble at the output of the AND gate, and there will be a NOT gate also, and put a bubble at the input of the OR gate, and also a NOT gate. So now we will cut this. Okay, now redraw this circuit with the help of NAND gate only. Okay, so this is how we can design a XNOR gate using NAND gate only, using bubble method. Now we have to design with the help of NOR gate. So like NOR gate is also a universal gate, like NOT gate. We have to design the NOT gate with the help of NOR gate. So expression for the NOT gate is y is equal to A bar, and for NOR gate it is y is equal to A plus B bar. So if A is equal to B, we will put A is equal to B, then this NOR gate will be A plus A bar. So it will be A bar. So it means like if this is a NOR gate and both input are short, so this will work as a y is equal to A plus A bar, or we can say A bar. So we can design NOT gate with the help of a NOR gate by keeping both the input same. So this NOR gate will work as a NOT gate. So now the NOR gate realization, how we can do the NOR gate realization by using the bubble method. So implementation of the XOR gate with the help of NOR gate only. So XOR gate expression is y is equal to A bar B plus AB bar. Now we will design with the basic gate NOT, A bar. After that AND gate will be there, so it will be A bar B. A B, so it will be A B bar, like in this way. Now with the implementation with the NOR gate, now we have to think how we can convert every gate into NOR gate. So OR gate will be converted into NOR when we will put a bubble at the output of the OR, and to neutralize this bubble we will put a NOT gate also, and at the input of AND gate we will put a bubble, and for neutralize this bubble we will put a NOT gate, like in this way. Like AND gate will be converted into a NOR when we will put a bubble at the input of the AND gate. Like this is the AND gate, and we will put bubble at the input. So A, B, so here it will be A bar, B bar. So here it will be A bar dot B bar. That can be written as A plus B bar according to De Morgan's. So means the AND gate having a bubble at the input, it will work as a NOR gate. So now we can see the equal number of NOT gate, like 2 NOT gate here, so it will be neutralized here, like in this way. On the same line, if there are 2 NOT gate are there, we can cancel out. So now this will be like, this can be redrawn in this way. Okay, so this is how we can draw the XOR gate by using NOR gates only. फिर है implementation of XNOR gate with the NOR gate. So how can we design the XNOR gate by using the NOR gate? Like expression for the XNOR gate is A bar, B bar plus AB. So now draw this with the help of basic gates. So this is how we have drawn this equation with the help of the basic gates only, and we have to design the XNOR gate with the help of NOR gate. So we will put a bubble at the output of this OR, and here we also put a NOT gate here, and here at the input of the AND gate, and in this way we will put a NOT gate here. Okay, so this will be the case, and now we can see equal number of NOT gate is there. So these will be cancelled, and now this circuit will be redrawn in this way. Like so in this way we can see the XNOR gate can be implemented by using NOR gate with the help of bubble method. So now we have to redraw, we have to implement this expression with the help of NAND gate and NOR gate with the help of both gates. So for that we have to implement first of all with the NAND gate, and we have to, like this is A, B, C. After that, this is the AND gate. After that, like A, B, C. Like this is we have designed with the help of the basic gates. Now with drawing with the NAND gate, we will put a bubble at the output of the AND gate. Like in this way. Now it will be cancelled out. Okay. Now redraw this circuit by replacing all the gates here with the help of the NAND gate. So this is how we can realize this expression with the help of the NAND gate. And for NOR gate, draw with first of all with the basic gate. with the NOR gate, we will put a bubble at the output of this OR gate, and for the NAND gate at the input of this AND gate. Now two NOT gates are on the same line, so we will cancel out. Now we can see all these NOT gates are remaining, so we can redraw this circuit by replacing all the gates in this diagram with the NOR gate only. Now we can implement this expression also with the help of NAND and NOR. So first of all, we are doing with the NAND gate. So for that, we have to draw with the basic gate first of all. So this is the C bar, and then D, and then B, and OR operation is there, so it will be passed through the OR gate. So it will be ये है. This is the case. Now we can see we have to implement with the NAND gate. So for NAND gate, here it will be bubble and NOT gate is there, and here it will be at the input side, and our NOT gate will also be there here. Now same two NOT gate will be cancelled out in this way. Now this circuit can also be redrawn by replacing all the gates with the NAND gate, and for implementing with the NOR gate, we can design in this way. First of all, we will see this is the C bar, after that D, after that B. So it will be OR gate. Like in this way. Now for OR NOR, we will put bubble here. Okay, now it will be cancelled out. Now we can replace all the gates with the NOR gate. So this is how we can design this expression with the help of the NAND gate and the NOR gate using bubble method. So here also, if we want to make this design, this expression, like this is the case. We have to implement this expression by using the minimal number of universal gate. So we will see first of all that A plus B can be, this will be AB, so this will be A plus B, and this will be C will be passed with the NOT gate, so it will be C bar. So it will be A plus C bar. After that, it will be passed through AND gate. Now you are asked to implement this expression with the minimal number of universal gates. So we can see here in this expression, we can see two OR gates are there and one AND gate is there. So here number of OR gate is more. So this expression will be implemented with the NOR gate, because two OR gates are there. So number of NOR gate will be minimum, and only one AND gate is there. So number of NAND gate will be more. So for minimal universal gate, we have to implement this expression with the help of the NOR gate. So for that purpose, we will put a bubble here and NOT gate, here bubble and NOT gate, bubble, NOT gate, bubble, NOT gate. Now this will be cancelled out. So we can redraw this circuit like in this way. So this is AB and this is AC. So this is how we can design this expression with a minimal number of the NOR gate. If we design this expression with the NAND gate, then the number of gates will be more. So how can we think that we have to design with the NOR gate or the NAND gate? We have to see that whether the number of the AND gate is more or whether the number of the OR gate is more in the expression. So in this expression, number of OR gate was 2 and the number of the AND gate was only 1. That's why we have preferred for the NOR gate, not the NAND gate. Like we have another expression in this way, y is equal to AB and A bar, B bar, C bar. So so we have to draw this expression with the help of minimal number of the universal gates. So first of all, we will implement this with the basic gates. AB, that is AB. After that, this will be NOT gate, A bar, B, B bar, and then C, NOT gate, C bar, and then after that it will be AND gate, and then OR gate. Now we can see here the number of the AND gate is 2 and the number of the OR gate is only 1. So better we have to go for the NAND gate or the NOR gate. Since the number of AND gate is 2 and OR gate is 1. So this will be better if we implement with the NOR gate. Sorry, AND gate, because the number of the AND gate is more. So we have to design this expression with the help of the NAND gate. Like in this way. Now this will be cancel out. So now redraw this circuit with the help by replacing all these gates with the NAND gate. Okay, so we can see here the number of NAND gate here total are 5. Sorry, 6 NAND gates are there. So by using 6 NAND gate, we can design this expression. Or if we use the NOR gate, then the number of NOR gate will be more in comparison to this NAND gate. So we have to see that whether the number of AND gate is more or the number of OR gate is more. So if AND gate is more, we will choose the NAND gate implementation. If number of OR gate is more, then we will choose the NOR gate implementation. Like this was the bubble method. We can also use the De Morgan's theorem. For implementing these gates. Like we have to make the AND gate with the help of the NOR gate. So expression for the AND gate is y is equal to AB. So for using the De Morgan's theorem instead of bubble method, what we will do, we want to design the AND gate with the help of the NOR gate. So we will use two things, that is a double inversion or the De Morgan's theorem. So double inversion, here there is no bar, so we will use the double inversion. If there is already a bar over the variable, like if it was AB bar, then we will apply the De Morgan's theorem. But it is so, like it will be like A bar, B bar. So now we can design this circuit, like A bar will be in this way. This is A and this will be A bar. After that, this is B, this is B bar. And this is like A bar plus B bar bar. So this is how we can design the AND gate with the help of the NOR gate using De Morgan's theorem. And if we design the AND gate, like this was the AND gate, AND gate. Oh, sorry. Like this is the AND gate, like A and B. we have to design this AND gate using the bubble method, using NOR gate. So what we will put, you have to design the NOR gate. So we will put 2 bubbles here, because for implementing with the NOR gate using bubble method, we will put bubble at the input of the AND gate, and we here will put NOT gate also. So this circuit will be converted into in this circuit. So this was the using bubble method, and this was using De Morgan's. So we can see by using De Morgan's or by using bubble method, the same design will be there, the same number of gates will be there. So we can go for the bubble method or we can go for the De Morgan's theorem. Like this was for the AND gate using NOR gate. If we design the NAND gate, if you want to design NAND gate using NOR, so for that purpose we have expression y is equal to a b bar. So now we will have a bar here. So there is no need of applying a double inversion. We will simply put the we will simply use the De Morgan's theorem, that is a bar plus b bar. Now we cannot implement this expression with the help of NOR, because there will be required a bar over that. So for putting this bar, we will use the double inversion. So this is how we can design this with the NOR gate. Like this is how we can design this NAND using the NOR gate using De Morgan's theorem. In next lectures, we will be discussing other gates also using De Morgan's method and bubble method.